Geometry lesson 20. Geometry lesson 20. So just as a reminder of how this week is going to go, we're going to do lesson 20 today. We're going to do SMART goals tomorrow. So you've got an extra day before this assignment is due. Okay, this assignment will be due on Wednesday. Wednesday is also the day that we will review for your test. Okay, I've had to move up the test a day because on Friday's homecoming, so it's an early out day. Obviously don't want to test on an early out day, so we're going to have to review on a short day, right? Yeah, on Wednesday. Friday's an early out because it's homecoming. Like 12:45 early. No, I'm not gonna Here, let me hit pause on this. All right, so lesson 20 that we're looking at here is interpreting truth tables. Admittedly, probably not my favorite lesson. It really deals with converse, inverse, contrapositive stuff that we've already talked about. Conditional statement has the form of if P then Q. We've got several other statements that can be constructed from those conditional statements. The converse of if P then Q is if Q then P. You're just switching those things back and forth. And I probably should have just gone ahead and done this just because I don't like them using P and Q for maybe a noticeable reason that P's and Q's, they look real similar when typed up, right? I would rather have used maybe A and B or X and Y or something where the letters themselves look different enough that you can tell when they've been switched back and forth, or even if one then two for that matter. But in any case, the converse statement of if P then Q comes out if Q then P. The inverse is if not P then not Q, keeps the same order, applies negation. Again, we've covered this with wasn't this just lesson 19 that we did some of this stuff? 18, 19. Contrapositive, we flip and negate, so we get if not Q then not P. Hopefully we're familiar with that, right? This isn't new information to us. All right. I always love like my first class of the day because nobody wants to say anything. Everybody's, especially on a Monday, everybody's like zombies in here. Okay, Michael's asleep. We're just really struggling, all things considered. All right, what this lesson is really going to seek to do is it's going to bring up a new one, which is what is called a biconditional statement. Okay, which is a combination of a conditional statement and the converse. So basically, we use a biconditional statement if the statement is true and its converse is also true. Right? It has to meet those two requirements. The if P then Q and the if Q then P statement have to be true in order for us to do a biconditional. So a biconditional statement is true only when both of the original statement and its converse are true. And the form of a biconditional is not if and then, but it's going to give me statement, and then it's going to have something in the middle where it's going to say if and only if, and then it's going to be followed up with the other side of the statement. So it actually has its root is it's in the middle of it. If and only if is what our biconditional is going to be written. So if biconditional of if P then Q and if Q then P are true, what we're going to write is P if and only if Q. All right. So what ends up happening is we say hypothesis if and only if conclusion. You follow me? Okay. All right, from here they talk about truth tables. This is the part that I'm not super hip on this part of the lesson, but a truth table is a table that lists all the possible combinations of truth values for a given hypothesis and a conclusion in a conditional statement or statements that they form. Truth tables are useful tools because they show all of the true-false possibilities kind of at a glance. So basically what you're seeing in this first one is that if the hypothesis is true and the conclusion is true, then our if then Q is true. Okay? All right, and then they give me my next one, which is if my hypothesis is true and my conclusion is false, then it has a false truth value. And we've talked about truth values a while back. Okay, and this instance right here in the middle that's highlighted is the only time where I have a false truth value. This is what we have to have in order to have a counterexample, right? So when we talked about our lesson on counterexamples, right? That's what we were looking for. We had to have a true hypothesis and a false conclusion in order to have a false truth value, in order to say that that is a counterexample, okay? So, for instance, if an animal is a horse, then it has 4 legs. My counterexample could be a cow, right? It's an animal with 4 legs that is not a horse, right? That's a counterexample. It has a false truth value. Now, if my hypothesis is false and my conclusion is true, then my statement is still true. If my hypothesis is false and my conclusion is false, it's still true. I know that seems weird, right? That doesn't seem like it should be, but that's how this works. Okay? So what you want to be able to follow is the only time I'm going to have a false truth value is whenever it goes true-false in terms of hypothesis and conclusion. So the highlighted row is the only combination for which the statement is not true. For example, to prove that the statement, if a quadrilateral is equiangular, then it is a rhombus, is false. You need an example of an equiangular quadrilateral where P is true that is not a rhombus, therefore Q is false. Okay? Let's see if there's anything else in here. All right, compound statements. Compound statements, we see this whenever we start talking about inequalities, right? X is greater than something and less than something else. That's a compound statement. Okay? So it combines two statements using and or. Okay? Whenever I have an and, it's a conjunction. And we see that with, again, inequality statements. When we have the word or, it's a disjunction. When we write these things up on a number line, a disjunction is going to have arrows that go in opposite directions, right? When it's a conjunction, you're going to see that they run into each other. They fill in, okay? It's similar to a conditional statement, except that P and Q are related by and or rather than if and then. So a compound statement uses and as a conjunction. We've talked about that. Conjunctions have the form of P and Q. Okay. For example, statement P stands for I had bacon for breakfast, and Q stands for I had eggs for breakfast. If you had bacon and eggs for breakfast, that's a conjunction. Both of those things are true, right? Where if you had something else, because P and Q are both true, that's a conjunction. But if you had bacon and toast, the conjunction is false because P is true, but Q is not true. Okay, which brings you down here to our disjunctions, which is or. Compound statement, or is a disjunction. Disjunctions have the P or Q. For example, suppose a lunch menu offers the choice of soup or salad. You've been someplace, if you've been to an Olive Garden, right? You get your meal, and they say, do you want soup or salad? It's not both, right? It's a disjunction. Okay, those things are separate. As an appetizer, this is considered a disjunction because you can. Let's change the spelling on that. Shoes. Let's choose one or the other. It's just a very laid back way of saying you go ahead and choose that, one or the other. All right, so that's it as far as those things are considered. We're going to take about 8 minutes, 6 to 8 minutes here. Determine if this biconditional is true. If false, give a counterexample. A figure is a square if and only if it is a rectangle. Is that true? A figure is a square if and only if it is a rectangle. Is that true? Okay. Jordan says it's false. Can you tell me why it's false? Okay, so you've got 3 false statements kind of here to choose from. Let's pick the false statement that's actually true. All right, all squares are parallelograms with 90-degree angles. That doesn't necessarily give me a counterexample. D, a rectangle does not necessarily have 4 90-degree angles. Well, don't all rectangles by definition have 90-degree angles? Sure. All right, Mike? Okay, let's fix that a little bit. Not all rectangles are squares, but all squares are rectangles. Okay? what do we know about squares that isn't necessarily true of all rectangles? Right. Not all rectangles have the same side lengths, right? Whereas all squares have 4 congruent sides. Not all rectangles do. Okay? So you're looking at B for this. You were right, Jordan. You just needed to kind of narrow it down. A rectangle does not necessarily have 4 congruent sides. B should be our answer there. Okay? So in case somebody is watching the video but not listening, we want that right there. All right. We want to write this as a biconditional. An acute angle is an angle whose measure is less than 90 degrees. All right, well, so let's look at just the conditional statement of this. We would say if an acute angle, if it is an acute angle, then its measure is less than 90 degrees, right? That would be a statement that we could write from this, correct? Right, and we could look at the converse of it and say, if an angle measures less than 90 degrees, then it is an acute angle, right? Are both of those statements true? Okay, so the conditional statement is true and its converse are true, so we should be able to write a biconditional statement. Remember, my biconditional statement goes, hypothesis, if and only if conclusion. Okay, that's my biconditional. That's how I know it's a biconditional. It has if and only if in the middle. All right, so which one of these is my biconditional statement? All right, so I have somebody that says B. Okay, all right. So Mike is saying that an angle is acute if and only if it is not obtuse. You're right. He says it could be a right angle because right angles, are not obtuse. Okay, so let's get rid of that then. And do we notice about B? A and C don't have an if and only if in the middle, do they? All right, so neither of those can be biconditional. But if we had a test that didn't have multiple choices, we would still need to be able to figure this out. So an angle is acute. Notice that this is my hypothesis, right? Okay, acute angle. An angle is acute if and only if its measure is less than 90 degrees. Measure is less than 90 degrees is my conclusion, so it goes there with if and only if in the middle. Okay? You got to be able to identify a biconditional statement and know how to put it together. Okay? All right. Let's see, that was number 2. All right, number 3 for the conditional statement, write the converse and a biconditional statement. If a figure is a right triangle with sides A, B, and C, then A squared plus B squared equals C squared. Katie, can you help me out with the converse of that statement? Yep. Perfect. That's exactly right. Okay. She said she took her A squared plus B squared equals C squared. She put it at the beginning. She took the figure as a right triangle with sides A, B, and C and flipped those things around, which looks like the same converse that's being listed for, is A the right converse? Inverse has a not in it. So it's not A, okay, because we see not being showed up there and we see not being shown there, okay. We're not going to say it's B because we see A squared plus B squared show up at the beginning, right? It's not flipped, right? Because a converse we need a flip, so we know it's not A, we know it's not B, we know it's not. Well, let's look at C. Well, look at C. Do we see a problem here? Yeah, we see that not again, which is just negation, right? This is a contrapositive, right? C is a contrapositive where they flipped it and negated it. So it's got to be, are there any of them there? Oh, hold on. Hold on. I was premature. This has negation in it. But B, right? B has the right order because we've got a squared plus b squared equals c squared. Then it's a right triangle with a. All right, so B looks correct, right? Sorry, I jumped on that. Figure is a right triangle with sides A, B, and C if and only if a squared plus b squared equals c squared. So the biconditional is based upon, I shouldn't put an X next to it, let's put a check mark. So the biconditional is not based upon the converse statement, it's based upon the conditional statement. Okay, so we're not writing the converse and then writing the biconditional. Okay? So that would have been maybe where I would have messed up. I would have written the converse and I would have said, you know, if a squared, a squared plus b squared equals c squared if and only if it is a, you know, right triangle with sides A, B, and C, which really still wouldn't be wrong, but we want to write our biconditional based upon the original statement. Okay? Do we feel like we understand this, or does it seem like a lot of information? Do we feel okay enough to go ahead and get started? Yeah, I mean, it is just one new word. It is just one new term, but that doesn't mean that we won't get confused by it. So let's give you guys some time to work. I'll walk around the room and see if I can't help you out.